students, welcome to the GATE Academy. So welcome to the class. I hope you all are well and safe at the home. So please respond. I am waiting for the responses. You all are well and safe at the home. So basically this session is all about the newly added topic for engineering mechanics for GATE 2021. So in this session, we are going to discuss about those topics. So I hope there is only one topic which have been added for the engineering mechanics syllabus. And this is only for the civil engineering students, fine? So can anybody tell me which new topic is added to the engineering mechanics syllabus? Anyone? Which topic is added to the engineering mechanics syllabus for GATE student, for GATE 2021? Please respond. I am waiting for the responses. Okay, no issue. So I'll tell you that the topic which has been added for the civil students in the syllabus of engineering mechanics. So the topic name is, I'm writing here. So the topic name is free vibration of undamped single degree of freedom system single degree of freedom system. Fine. So I know that this topic is new for the civil students, because I don't think that they never studied about the vibration. So the reason is, as every structure is subjected to some type of dynamic loading. Now you will say, sir, how dynamic loading? Basically, we develop the structure for the static loading only, na? So how the system is subjected to the dynamic loading? Even you are creating any type of structure, but at all the time it is subjected to one type of dynamic loading. That is what? That is nothing but the wind load. As you know that the velocity of wind changes each and every time. It changes the direction each and every time. So what happens in that condition? That loading on any structure is converted into the dynamic loading. And I hope you all are aware about this concept, that any structure that is subjected to the dynamic loading, so the chances of failure of that structure increases by many times. Fine. So for such conditions, there is a requirement to study the concept of vibration. Because what happens whenever any system, for example, you are designing a pillar, and that is subject, you are designing a large pillar, and at each and every instant it is subjected to large amount of wind. In that condition, what happens? So in that condition, the magnitude of wind load is continuously changing. So correspond to that, what happens? If this column vibrates along the transverse direction. So I hope that you are aware with the concept, term transverse direction. Fine. So in that condition, that structure is subjected to the transverse vibration, and we see that after some period of time that structure may fail. Due to those transverse vibration. So in order to take care of that vibration, how we can reduce that vibration, how we can measure that vibration. So these all analysis come inside the free vibration. Fine. Sorry, these all analysis come under the concept of vibration. But because this is a new topic for civil students, that's why the IIT added a very small portion of that vibration. Now they will see how you are interested in this topic. So there may be chances that in upcoming time the portion for the vibration can be increased. Fine. So be prepared for that. So in today's class, we are going to discuss only about the free vibration. So what do you understand by the free vibration, and what do you understand by the undamped, and what do you understand by the single degree of freedom? So these all things we will discuss in this class. And I hope that if you are much interested for the GATE examination, then I hope that you observed one question was asked from the vibration in GATE 2019 paper of civil engineering. What was that question? That question we will also discuss in this class. Fine. So for complete understanding of vibration, please be with the lecture up to the last, and please share this session with your friends also if you found that sufficient information is given to you. So please share this session with your friends also. Fine. Now, so before starting the session, first I want to tell about myself. So who am I? So myself, Vikalp Tiwari, and I am the subject matter expert in the GATE Academy for basically mechanical engineering, and I deal with the subject engineering mechanics as well as the theory of machine. So this topic, that is vibration, that is a part of theory of machine. That's why I taking the session on this topic. So right now I am going to start the session. Fine. So the topic name is free vibration of undamped system. So before starting this topic, I just want to know what is the vibration and what is the basic idea that you have about the vibration. So please tell me, what is the vibration? I am waiting for the responses, because when you will respond, then I will understand that what is the level of you in this topic, and as per that I will move in the session. Right? So please respond. What is the vibration? What is the idea about the vibration? So okay, so my chat was not visible. Right now I refreshed it. So most of the people have answered undamped degree, single degree of freedom. Ram is saying free vibration, very good. And Vinay is asking, sir, will you provide yesterday's lecture of class notes? Vinay, I think it is already, the link is provided to you, so you can download the notes from that link. Fine. Good morning, Frozen. And Hitesh is asking, is this for mechanical? So as I have already told you, that this session is basically for the civil engineers, because this syllabus is this topic is added in the syllabus of engineering mechanics for civil students only. Okay, Hitesh. And yeah, it is a new syllabus. So Tazim is asking, sorry, Tazim is answering that the vibration is what? To and fro motion. Very good, Tazim. And Harshal is saying small amplitude oscillation. Very good. Ramsudar is saying back and forth motion. Very good. So Nadeem is saying disturbance, to and fro motion. Second. So very good. You have the idea about the vibration. So that definition is very simple. So what is the definition? So right now, first we will discuss about the vibration only. What is the vibration? And later on we will discuss what is the free vibration, and after that we will understand what is the single degree of freedom system. Is it okay? So first I will define the vibration. So vibration is nothing but vibration. So it is nothing but, it is the to and fro motion, to and fro motion, to and fro motion of a body about its mean position, about its mean position. Fine. So vibration is what? It is nothing but to and fro. To and fro. What do you understand by the to and fro? Either the term to and fro or the term back and forth. All terms are same. So the to and fro. For example, a body. I am taking one example of pendulum. So I hope you understood what is the pendulum. So let us assume this is a pendulum. Now what will happen? Up to when there is no disturbance force on the system, the system will remain in static equilibrium. That means the system will remain at rest. But what happens? Suppose some disturbing force come into the action, and what it do? It displaces the system from its mean position. As you know that this is the mean equilibrium position. So when you will apply a force, or for example, you are hitting this pendulum with one hammer. So what will happen? Correspond to that, the system will displace, and this is the new position. Now, so what is the vibration when the system is displaced from its mean position? This is nothing but the mean position. So when the system is displaced from its mean position, in that condition, the system performs the to and fro motion about its mean. So this is the mean position. So the body goes like this, again like this, and again like this. So after certain interval of time, it repeats its path about the mean position, and this motion is known as the vibration. So this is all about the vibration. Now here we will discuss which type of motion performs a body during vibration. So it is very important. During the vibration, a body performs the simple harmonic motion. During a vibration, the body performs the simple harmonic motion. So during vibration, body performs the simple harmonic motion. And vibration is what that I have already written here, harmonic motion. Now this term is new to all. What is simple harmonic motion? So what is simple harmonic motion? So it is nothing but it is a type of oscillatory motion, or it is a type of periodic motion. Now what is the periodic motion? So first we will see what is the periodic motion. Later on we will see what is the simple harmonic motion. Is it okay? And if you have any doubt, then you can ask your doubt in the comment box. Fine. So feel free to ask your doubt. So first we will discuss about the periodic motion. Periodic motion. Now, I think this term is self-explanatory. So can anyone define can give me the definition of this term? What is the periodic motion? Because the term is self-explanatory. Periodic motion. Can anybody answer? What is the periodic motion? Anyone? Okay, so Nadeem is saying that repeated in equal interval of time. Very good, Nadeem. So what do you understand by the periodic motion? A motion is said to be periodic if it repeats its path after a certain interval of time. So what is the periodic motion? A motion which repeats its path, after certain interval of time. Fine. So all such type of motion is known as the periodic motion. Fine. And simple harmonic motion is a subtype of periodic motion. So what is the simple harmonic motion? Simple harmonic motion is a subtype of periodic motion. All the simple harmonic motion are the periodic motion, but all the periodic motion are not the simple harmonic motion. So for this, first we have to understand what is the periodic. So what can be the periodic? For example, if we take an example, for example, this is the earth and this is the sun. So as you know, this earth revolves about the sun, this earth rotates about the sun. So what happens after a certain interval of time, or you can say that after 365 days, what happens? It again repeats its path I draw the path, I draw the orbit of this Earth is circular in nature, but it is not in circular, it is some elliptic. But for example, we are considering that Earth is performing this type of motion, and after 365 days, after each 365 days, it repeats its path. So because it is repeating its path after a certain interval of time, that is 365 days, so we can say that it is a periodic motion. In the same way, you can say that whatever we have discussed here, the pendulum, as you know, when we will displace this pendulum, so it will go from mean position to the extreme right position. After that, it returns back to the mean position, and again it moves to the extreme left position, and again it comes to the mean position. So this complete path is known as one cycle. This complete path is known as the one cycle, and you will observe that after certain interval of time, it again repeats its path. So such type of motion is also known as periodic motion. Now, what is the difference between periodic motion? So what is the difference between periodic motion and simple harmonic motion? So that I will discuss here. So what can be the example for a periodic motion? All types of vibration are the example of periodic motion, and all types of or the motion of the earth about the sun is a periodic motion. You are revolving a stone about one axis, that is the example of periodic motion. Now come to the simple harmonic motion. So what is the simple harmonic motion? That I will discuss here. Okay, Prashant. So Prashant answered that the motion produced at certain interval of time. Very good, Prashant. So now we will discuss how the simple harmonic motion is different from the periodic motion. Is it okay? So next is simple harmonic motion, or generally we call it as SHM. I hope that you are aware with this term, that is SHM. So SHM is what? It is a periodic motion. It is a periodic motion. It is a periodic motion. In which acceleration of the body always acts towards the mean. Always act towards the mean position. So SHM is what? It is a type of periodic motion in which this term is very important for all type of vibration, for all type of simple harmonic motion. The acceleration of the bodies always acts toward the mean position. And I hope that you know very well about the acceleration. So acceleration is nothing but this is the rate of change of velocity. So if in any periodic motion, the acceleration of the body is always towards the mean position, such a type of motion is called as the simple harmonic motion. Now you want to know what do you understand by the acceleration is always towards the mean position. So now I will explain what is the mean of that term. So whenever the acceleration always towards the mean position, so it suggests when the body will move away from the mean position, then its velocity will decrease with respect to time. Because what is the acceleration? It is the rate of change of velocity per time. So whenever a body moves away from the mean position, its velocity continuously decreases. But when the body comes towards the mean position, its velocity continuously increases. And I hope that you have observed in case of pendulum. So when the pendulum moves from mean position to pendulum moves away from the mean position, in that condition, what happens? Its velocity continuously decreases. So its velocity continuously decreases, and you will acquire a position at which the net velocity is equal to 0. but when again it starts to move towards the mean position, its velocity starts to increase. Its velocity starts to increase, and up at the mean position it have the maximum velocity. And because at the point of at the mean position it have the maximum velocity, that's why it not stop at the mean position, so it crosses the mean position. So because right now it is again crossing the mean position and it is going away from the mean position, so its velocity continuously decreases and again it reaches to zero. Now again it comes to the mean position, so its velocity again increases, and it will again have the maximum velocity at the mean position. So in this way, the motion, so all the type of motion which follow such type of phenomena, so such type of motion is known as the simple harmonic motion. Is it okay? Now this concept, this term is clear to you. If is there any doubt? If you have any doubt, then you may ask, otherwise you may proceed. Fine. So Taizim is asking, sir, what is the undamped single degree of freedom? So Taizim, please wait for 5 to 10 minutes. You will get to know that what is the undamped single degree of freedom, because I have already told you in your syllabus all that I will tell you definition of all the terms, what is the vibration, and later on we will discuss what is the free vibration. Please give me 1 minute. 1 minute. So after that we will discuss what is the free vibration, and later on we will discuss what is the undamped degree of freedom, what is the undamped term, and what is the SDOF single degree of freedom. So please wait for 5 to 10 minutes. You will get to know what is the meaning of that term. Okay, fine. So Prashant is saying, sir, at first when we apply the force at pendulum, the velocity increases. No. So Prashant is saying, sir, at first when we apply the forces at pendulum, the velocity increases. So Prashant, here we are talking about the free vibration. The body will, so what is the free vibration? Once you will understand the definition of free vibration, then you automatically get the answer what you are asking. Fine. So first understand all the term. After that you will get to know that what is the mean. Fine. So please wait. If you still not get the answer, then I will tell you. Fine. So please wait. Now, so I hope that right now the term SHM is clear to you. So during the vibration, all the body performs the simple harmonic motion. That means during the vibration, the acceleration is always x towards the mean position. So right now we will discuss about some term, that is what is the displacement equation during vibration, what is the velocity equation, and what is the acceleration equation. So as you all know that what is the equation of SHM? Can anybody tell me what is the equation of SHM? What is the equation of motion during SHM? Anyone? What is the simple equation of SHM? Simple harmonic motion. So I will tell you what is the equation of SHM. Yeah. Prashant is saying F is equal to Kx. So Prashant, F is equal to Kx. It is nothing but the spring force. So okay. And yeah, very good. I don't know who is AS. So AS is saying it is nothing but X is equal to X small x. This is nothing but the displacement. So X is equal to A sine omega t plus phi. So this is nothing but this is the displacement equation during SHM. If at any time, if at any instant of time you want to know what is the displacement of that system from the mean position, so X is what? X denotes the position or the displacement from the mean position. X denotes what? X denotes the displacement from the mean position. From the mean position. Fine. So if you want to calculate the displacement of any system from the mean position at any instant of time, t represent the time. So if you want to know the displacement of any system from mean position at any instant of time by using this equation, you can get what you can get. You can get the displacement value. Now, what is the A? So A is nothing but it is the maximum amplitude. It is nothing but the maximum amplitude during SHM or vibration. This is nothing but maximum amplitude during vibration. So if our body is performing vibration, then during that vibration, what is the maximum amplitude of vibration? So that denotes the A. Now what about the phi? So phi is nothing but it is the phase angle. It is nothing but the phase angle. So these A and phi are the constants, and it depends upon the initial disturbance. Now what is the initial disturbance and what are the initial condition? That we will discuss when we will derive the equation of motion for a simple spring mass system. So please wait for the conditions of A and phi. So understand please, phi is nothing but the phase angle, or it is nothing but the phase angle. Fine. So this is all about the displacement. Now if you want to know what is the velocity, then what can be the velocity? So if you want to know what is the velocity, so velocity is nothing but v, or we can write it as x dot. So x dot is nothing but dx over dt. So if we will differentiate this term with respect to time, so what you will get, because A is a constant, so it will come outside. What is the differentiation of sine omega t? So the differentiation of sine omega t is nothing but cos omega t plus phi. And what is the differentiation of omega t? So you will get omega outside. So this is nothing but this is nothing but the velocity during SHM. So we will closely observe this velocity. So you will get x dot is equal to a omega cos omega t plus phi. We can write it as sine omega t plus phi by 2. So what is this? This is nothing but the equation of velocity during SHM. Now what it represents, as you know, in each simple harmonic motion, the coefficient of this sine function, the coefficient of this harmonic function represent the amplitude. So what is the maximum amplitude during velocity? So the maximum amplitude during velocity is nothing but the A omega. In each and every simple harmonic motion, whatever will be the coefficient of that harmonic function, that will be the maximum amplitude of that term. So in this case, the coefficient is capital A, so it is nothing but the maximum displacement is capital A. Here the coefficient of harmonic function is A omega, so the maximum velocity is what? Maximum velocity is A omega. Now what can we understand by this term? This omega represent the frequency of vibration. With what frequency? Frequency is what we will discuss here. So frequency is nothing but it is the number of cycles in 1 second. So what are the number of cycles? So it represent in 1 second. So it represented by omega. And omega is what? Omega is known as the angular frequency. Omega is known as angular frequency. And if you are talking about, and its unit is what? So the angular frequency unit is nothing but it is radian per second. And if you want to know the frequency in terms of cycle, so it is nothing but it is equal to f. So f is nothing but it is equal to omega by 2 pi. So if you want to calculate the number of cycles in terms of hertz, so if you want to calculate the frequency in terms of number of cycle, so what we will do, you will divide the angular frequency with the 2 pi, then you will get the frequency in terms of cycle or hertz. Fine. Now, so this is the maximum amplitude of the velocity. The frequency of displacement and the velocity will be same, because as you can see, omega is common in both the term. Now what do you understand by the pi by 2? So from here we can conclude that velocity leads the displacement vector vector y 90 degree, vector by 90 degree. Now what do you understand by the 90 degree? So I will show it to you that what is the physical meaning of that term. For example, there is the displacement equation. There is a displacement equation of any system is something like this. We are drawing a curve for x is equal to capital A sine omega t. We are assuming that initially the phase difference, phase angle is 0. Fine. So correspond to that. It is nothing but it is a sine cycle. So we will draw a cycle something like this. Is it okay? So what is the time period? So for the time period of the cycle will be 2 pi. And what is the maximum amplitude? So maximum amplitude, it is nothing but A. So this is what? This is nothing but the displacement versus theta graph. Fine. Now, what do you understand by this term pi by 2? So it represent the vibration, the velocity during SHM will be sine in nature. So obviously it will be a sine curve. It will be a sine curve and it is leading by pi by 2. So what do you understand by the pi by 2? So when plus or leading sign is mentioned, then what we will do? We will draw a curve like this. We will draw a curve like this, for example. So here the velocity. So right now we are going to draw the curve in between velocity and the angle theta. So what it will be? So when it leads the displacement by 90 degrees, so what we will do? We will move this complete vibration displacement equation by 90 degree in backward direction. So when you will move this displacement equation by 90 degree in backward direction, then you will get the curve something like this. So as you can see that this wave, this velocity is leading the velocity vector, displacement vector by 90 degrees. So this is the physical meaning of this equation. And what will be the maximum amplitude during velocity? So the maximum amplitude during the velocity is nothing but a omega. So this is the velocity equation. Now I hope this is clear to you. So Aman is saying, can you repeat this last two steps? Okay. So Aman is saying that please repeat these last two steps. I hope this differentiation is clear to you. So what the equation represents? So in the equation, the coefficient of t represent the frequency, angular frequency, and the coefficient of this harmonic function represent the maximum amplitude, and this additional part represent the phase angle. So as you can see, the angle for displacement vector is omega t plus phi. But what about the velocity? So what about the velocity? As you can see, this is nothing but this is the angle of the displacement, but the velocity equation is leading the displacement by pi by 2 degree. So if we will draw a curve, so it will be a cos curve, because as you can see, the velocity is nothing but a cos curve. So if you want to draw, so what do you understand by this equation? When we will move the sine equation, when we will draw our sine equation by leading pi by 2 angle. As you know, this is 0 degrees, this is pi degree, pi by 2. Sorry, this is pi by 2. This is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi by. So because that the velocity vector is leading the displacement by pi by 2 degree, that means our velocity will start something from here. So the equation, so that graph will be something like this. Fine. And what will be the maximum amplitude? So I am representing here, this is the maximum amplitude. Fine. Now, so basically I am explaining this term. Why? Because you should have clear understanding about the equation of motion. Now I will not explain about this term because I hope this is clear to you. So what about the acceleration during SHM? Acceleration. So acceleration during SHM is nothing but it is x double dot, and we can write it as dx dot by dt. So we have already x dot equal to what? X dot equal to nothing but it is a omega cos omega t plus phi. So when you will differentiate, what you will get? You will get x double dot minus a omega square sine omega t plus phi, or you can write it as a omega square sine omega t plus phi plus pi. So what do you understand by this equation? What do you understand by this equation? If somebody asks what is the maximum acceleration during SHM, can anybody answer what will be the maximum acceleration during SHM? Anybody? What will be the maximum acceleration during SHM? Because right now you have the equation. What will be the maximum acceleration during SHM? Very good. So AS is saying it is nothing but a omega square, because I have already told you in every vibration equation, in each equation of motion, the coefficient of harmonic function represent the maximum value. So because it is the acceleration, so it represents the maximum magnitude of acceleration. And what will be the frequency of acceleration? It is nothing but omega. And what is the leading of that acceleration vector? So see here, as it is given here that acceleration leads the displacement vector y vector by y pi, or you can say this 180 degree, and leads the velocity vector by 90 degree. So again, it is a key point. What is the key point? That acceleration leads the displacement vector 180 degree, because what is the angle of displacement vector? That is omega t plus phi. So it is leading the displacement vector by pi radian, or you can say this 180 degree. And what is the angle of velocity? So that is omega t plus pi by 2. That means it is leading the velocity vector by 90 degree. So this is all about the simple harmonic motion, and this is all about the information in the simple harmonic motion. Now the same equation you can write in another term. So what is that term? So I am writing here, as you know, this is nothing but x square x double dot minus, if we are taking omega square common here, then what is this? This is nothing but a sine omega t plus phi. And what is this? This is nothing but this is the displacement only, na? So we can write it as omega square x. So here we can write x double dot plus omega square x. This is another form of acceleration. This is the another form of acceleration in terms of displacement. So this is also known as the equation of motion of SHM in terms of acceleration. This is the equation of motion in terms of acceleration. So if at any time you will get any equation in these term, then that body is performing the simple harmonic motion. Then that body is performing the simple harmonic motion. So this is the equation of motion in displacement, equation of motion in terms of velocity, and this is the equation of motion in terms of acceleration, and this is the equation of motion in terms of acceleration as well as the displacement. So most of the time in vibration problem you will get the equation of motion something like this. So please remind this equation in your mind, and because we are going to face similar type of situation in the vibration problem. Fine. So Prashant is asking, sir, what is the amplitude? Prashant, I already told you that at each and every equation of motion, the coefficient of harmonic function is what? Coefficient of this term. So what is the coefficient of this term? That is nothing but a omega square. So it will always represent the maximum amplitude of that quantity. So quantity is what? That is the acceleration. So it represents the maximum amplitude of acceleration. Is it okay? Now, so Aman is asking that what is the theoretical meaning of leading the acceleration and velocity by 180 degree and 90 degree. Okay, so Aman, that you this term you will get to know that, and it means what? It means what? As you can see here, I am just explaining. For example, this is the displacement equation. So when you will draw the velocity equation, then you will get something like this. Sorry, you will get. So please see here. So when you will draw the velocity equation, then you will get something like this. Is it okay? And when you will draw the acceleration graph, so acceleration graph will be something like this, because when you are leading by 180 degree, that means when you are leading by 180 degrees, so graph will start something like this. Now understand this, please understand this. What is it represent? It represent the mean position. So it represent when the body is at mean position. In this condition, the body will have the maximum velocity and the body will have zero acceleration. As you can see here, that acceleration is directly proportional to the displacement. If the displacement will be maximum, its acceleration will be maximum, and when the displacement is maximum, its acceleration will be maximum, and when the displacement is zero, at that condition the acceleration will be equal to zero. Now understand here. As you know, I think you have observed in case of pendulum, when it is at the mean position, it have the maximum velocity, and at that instant it have the zero acceleration. Why zero acceleration? Because at that condition it have the zero displacement from the mean position. So this is the simple understanding about the acceleration velocity and the displacement relation. So by this graph we can find out that what will be the condition for velocity, acceleration and displacement. So simple, with this graph we can conclude. So this is all about the SHM. Right now we are going to start the the elements of the vibration, because right now you have cleared the concept of vibration. Right now we will start the elements of a vibrating system. Vibrating system. So what are the essential element? For a vibrating system? So see here, this is very important. So what is this? In a vibrating element, there should be an inertial element. And as you know that inertia is what? Inertia is nothing but it is the property due to the mass. That means inside the system something should be there which carries the mass. So inside the system there should be something which carries the mass. So what type of why mass is necessary? Because as you know, what is the momentum? I hope you have studied about the momentum. So momentum is nothing but it is the quantity of motion. And as you know, it is represented by m into v. That means in order to carry the motion, your body should have the mass. So vibration is nothing but it is a type of motion. So what is the first element that should be inside the system? So that is nothing but the inertial element. Why? Because it stores the motion inside itself. Fine. So there should be one inertial element. That means element which carries the mass. Now what should be the other element? So another element is nothing but restoring element. Now what is the restoring element? Inside the system there should be at least one element which is trying to bring the system at mean position. So these two elements are very important. If inside your system these two elements are not there, then your system do not vibrate. then your system will not vibrate. So these two elements are important. Now again listen, what is the restoring element? So element which is trying to bring the system towards its mean position at all instant of time, that system is known as the restoring element. Otherwise what will happen? When you will displace the system, then the system achieve a different position. So vibration, when the vibration will occur, so when you will displace a system in that condition, that restoring element, when you will remove the force, so at that condition that restoring element will try to bring the system in its mean position. So due to this restoring elements, the vibration performs. So both elements are important, and in absence of any one element, the vibration cannot be performed. Fine. Now, what is another parameter? These elements may be inside the system or may not be. So what is the another element? So next element is nothing but it is a damping element. Now what do you understand by the damping element? So whenever you will see a term damping, then only one thing should become your mind. What is that? That is what? Friction. That is what? That is nothing but friction. So there may be a friction of element which is producing the friction inside the system, or there may not be any element which is producing the system. Why? This system is required. So this system is required on, this system is responsible to gradually reduce the vibration, to gradually reduce the vibration in each cycle. So as you know that friction is responsible for the degradation of energy. So what happened when frictional element, when damping element is inside our system, so correspond to that frictional element, what happens, and in each cycle the total energy of the system is wasted. So it is gradually decreases. So as you have observed, when you displaces a pendulum from its mean position, so after some interval of time, what happens? It comes to its mean position. So why it comes to its mean position? It comes to its mean position because of the frictional or the damping element only. Is it okay? Fine. Now what about another term? So there is one more term, that is the excitation force. Excitation force. So now what is the excitation force? In your system, inside your system, there may be a excitation force which is continuously disturbing the system. So such type of forces is known as the excitation forces. And keep one thing in your mind, always inside a vibrating system, if any external force is acting, then the system will vibrate only when the excitation force is harmonic in nature. If any external force is acting on your system, then system will vibrate only when that force is harmonic in nature. Now what do you understand by the harmonic in nature? That means either the force is changing its direction at each and every instant, or its magnitude is changing at each and every instant. So that means the type of load should be a dynamic load. As you know, in case of wind, what is the wind load? Wind load is nothing but it is a type of harmonic force, or it is a type of dynamic load. Why? Because at each instant of time, either the velocity, either its magnitude changes or its direction changes. That's why correspond to the wind load of our system vibrates. Otherwise, what will happen if you will apply a static load? So correspond to that load, your system will show a static deflection, and the system will maintain at that position only. Fine. So for the system, for the external excitation force, the system will vibrate only when the excitation force is harmonic in nature. But these two elements may or may not be inside the system, may or may not be. But in order to make a vibrational system, these two elements are must. I hope it is clear to you. Now, so this is all about the elements of vibrating system. Now we will discuss about the type of vibration. So here up to now your vibration term is clear, and what are the components, what are the elements inside the vibration system. This thing is clear. Now we will discuss about the types of vibration. Here the term free or forced will be clear to you. Types of vibration. So can anybody tell me what are the types of vibration? I know that this topic is new to you, but do you have any idea about the type of vibration? What are the types of vibration? If you have any idea, then please respond. Yeah, very good, Nani. So Nihant is saying it is 6 types, sir. So Nihant, it is not 6 types. Basically, the vibration on the basis of forced condition. So basically, vibration is categorized into 2 parts. First one is free vibration. Very good, Raghu. Free and forced. So basically, it is free vibration and forced vibration. Forced vibration. Now, free vibration is also known as the natural vibration, as Rahul gave the name. Sorry, yeah, Raghu gave the name. Free vibration is also known as the natural vibration. Natural vibration. Now, so Nihant is saying free, undamped, damped, linear, non-linear. So Nihant, I will discuss all type of vibration here only. So please see here. So basically that the vibration is categorized into 2 parts. First one is free vibration or the natural vibration, and second one is forced vibration. So what do you understand by the free vibration? So free vibration means there is no external force. There is no external excitation force. No external excitation force. But you will say, sir, you are saying that first our system will displaced from its mean position, then obviously there will be a force. Definitely, when the system is displacing, so always the displacement will occur correspond to a force. But during the vibration, during to and fro motion about its mean position, if no external force is acting, no external excitation force is acting on the system, no external excitation force is acting on the system, then such type of vibration is known as the free vibration. For example, there is one pendulum and I am applying some force and I am displacing it from mean position, and right now I am relieving, then what will happen? Because its stiffness is so much high. So in that condition, when you are taking an example of simple pendulum, so when you will displace the system, up to this condition you are applying a force, but it is not performing the vibration. Now when you will release the force, in that condition what will happen? It continuously vibrate, and after that, after certain interval of time, due to the friction, it will lose its complete kinetic energy and it will come into rest, and such type of vibration is known as the free vibration. So I hope this term is clear to you. What is the free vibration? If there is absence of the external excitation force, then such type of vibration is known as the free vibration and natural vibration. And write down here one more term. During the free vibration, body vibrates with natural frequency. Body vibrates with its natural frequency. Because there is no restriction on the system. So body will vibrate with its natural phenomena in its natural way. So it will perform the number of cycle what the system allows. So what is the natural phenomena, natural number of cycle that it can perform in a period of time, in a certain time period. So in a certain time period, that is known as the natural frequency. So during the free vibration, body vibrates with a natural frequency. Is it okay? Is there any doubt? If there is no doubt, then we will discuss the forced vibration. So what is the forced vibration? It is in the presence. It is in absence. It is in absence of external excitation force, and it is in presence. PRESENCE. It is in presence of external excitation force. So if inside your system, external excitation force is acting during the vibration. If inside your system external excitation force is acting during the vibration, then such type of vibration is known as the forced vibration. Now, how we can understand this? For example, there is one pendulum, and on your pendulum there is one harmonic force is acting. I already told you excitation force always will be harmonic in nature, then only the system will vibrate. And suppose this force is vibrating in nature, and that means its amplitude is decreasing, its amplitude is changing, or its direction is changing. So correspond to that, the system will vibrate. And whatever will be the frequency of the force, the same will be the frequency of your vibration. Because if the force has less frequency, then it will vibrate like this. If force has the more frequency, then it will vibrate like this. So during the forced vibration, the system vibrates with force frequency. So it is the forced vibration. Is it clear to you, or is there any doubt? So during this forced vibration, body vibrates with the force frequency. Vibrates with force frequency, not forced. Whatever will be the frequency of force, that will be the frequency of vibration. So body vibrate with force frequency. Now, I hope you have here one term, that is what? Resonance. So now what is the resonance? So resonance will always occur in case of free vibration, forced vibration. So what is the condition of resonance? Suppose if the frequency of force, matching with the natural frequency of the system, if your force frequency omega is matching with the natural frequency of the system, in that condition you will see that the maximum amplitude of vibration will occur, and that condition is a resonance. For example, let us assume there is one pendulum, and you are applying a force, over on it with a frequency of omega. And as you know that the natural frequency of the system is what? That is nothing but the omega n. So if the natural frequency of the system is omega n, and you are continuously increasing, changing the frequency of force, so when your force frequency will become equal to the natural frequency, so in that condition what will happen? So at resonance, what will happen? If your system is running at resonance condition, so in that condition what will happen? At each and every cycle, your amplitude will continuously increases, and after a certain interval of time you will see there will be an infinite amplitude of vibration. That means your system may fail. So such type of condition is known as the resonance. Is it clear to you or not? So we should always avoid such type of resonance frequency. I hope you have heard that in foreign there was a bridge which was collapsed due to this resonance phenomena. Why resonance phenomena? Because they constructed a bridge at that time, they have no idea about the vibration. And so when the army was passing, through that bridge, it matches with the natural frequency of the bridge, so it is subjected to the resonance and correspond to the resonance condition, that bridge was failed. So after that, the analysis was done that why bridge was failed, so that resonance concept came into the picture. So we should always avoid our system for this resonance condition. So how we can avoid? As you know that always the phase resonance will occur only when your excitation frequency matches with the natural frequency, and this natural frequency we can easily calculate. Why? Because this natural frequency is dependent on system dimension. system parameters. What are the system parameters? What is the stiffness of the system and what is the mass of that system? So it depends on two parameters, stiffness and the mass. So by these two terms we can easily calculate the natural frequency. So if we know the natural frequency of our system, then we will try that certain building, certain system, certain pillar is not subjected to that much frequency. Fine. So this is all about the resonance. Is there any doubt? If you have any doubt, then you may ask here. Otherwise, I will proceed. Please respond. I know that this topic is new to you, but I hope that this is a very important topic, very interesting topic. So please respond. Is it clear to you or is there any doubt? So this is all about the free vibration. I hope right now the term free is clear to you. That means you are going to study only those portion, you are going to study only those topics which is performing the free vibration. That means in your syllabus, the system you will study that is not acted upon by any external excitation force. The system will act, the system will perform, the system is vibrating under its natural frequency only. Is it okay? So this right now the free vibration is clear to you. So now we will move to the damping. So as I have already told you, damping means what? Can you tell me? Damping means what? What is the damping? Because I have already told you. What is the damping? What is the damping? Anyone? I have already told you, right? Damping element. So what do you understand by the damping? Yeah, very good, Tazim. Very good, Akshat. So damped system means a system in which there is vibration, there is friction. A system in which there is friction. So what friction do? Friction will reduces the overall energy in each successive cycle. So correspond to that friction force, our system reduces its energy in each successive cycle. So our system comes to at rest. So damped means a system in which there is friction force. There is friction only. Fine. So now what do you understand by the undamped? Undamped means a system in which there is no friction. I hope that now undamped term is clear to you. Is it clear? To gradually reduce the vibration per cycle. Very good. Sir, what should be the relation between natural frequency and forced frequency? What should be the relation between? Prashant. So Prashant is asking, sir, what should be the relation between natural frequency and forced frequency? So Prashant, actually this is not the part of your syllabus, but I will tell you, actually there is no dependency on natural frequency or the force frequency, because force frequency is what? At what frequency of force you are using, how many number of cycles in 1 second, how many numbers of cycles it is performing, and you can change it very easily. For example, this is our system. I know that the natural frequency of the system is omega n, and we can apply a force of a system frequency like this. We can apply a force of frequency like this. So we can change the excitation frequency of force. So if it is matches with the natural frequency of system, in that condition only the resonance will occur. So force frequency may be any. something can be the force frequency, whatever at what frequency of force you are applying, that will be the force frequency, but there is no direct relation. But we should avoid the condition that force frequency should not match with the natural frequency of the system, in order to overcome the resonance, in order to avoid the resonance. Is it okay? Now, so I hope that free term is clear to you, vibration is clear to you, and undamped is clear to you. So what do you understand by the free and damped? What do you understand by the free and damped? Can anybody tell me what do you understand by the free and damped system? Because I have already told you about the free system. I have already told you about the undamped system. So can anybody tell me what do you understand by the free and damped system? Free and damped system. Obviously, it is very clear. Free means there is no external excitation force. Undamped means there is no friction force. That means if inside our system there is no frictional forces, no external excitation forces, such a type of system is known as the free undamped system. And for civil student, we will deal with such type of system only. And as you know, during the free system, the system vibrate with the natural frequency. So most of the question you will get related to the natural frequency only. In your syllabus, in your engineering mechanics part, you will get only question related to the natural frequency. That means inside your exam, they will ask what is the natural frequency of the given system. That is the question. This question only you can obtain in your examination. So basically, in this complete topic, you will study how we can calculate the natural frequency of the system. Fine. Now, so there is one more portion, that is what? That is nothing but the degree of freedom. And I hope that you are aware about the term degree of freedom. So can anybody tell me what is the degree of freedom? What is the degree of freedom? What is the degree of freedom? So Vamsi replied without external forces. Taizim replied no frictional with free vibration. Very good. Okay. Possible direction of motion. Yeah. So degree of freedom is nothing but. So how we can define that degree of system? So sorry, degree of freedom. So degree of freedom is nothing but it is independent. It is the number of independent motion. Independent. It is the number of. It is the number of independent coordinates. Independent coordinates that is required. That is required to define. That is required to define the state. That is required to define the system completely. System completely. So what is the degree of freedom? You may define the degree of freedom in a way that it is the number of independent motion that a body can perform, or you can define a degree of freedom like this, that it is the number of independent coordinates that is required to define the system completely. That means, so coordinates means those coordinates which are defining the system completely. For example, we are taking one example of a spring mass system. So there is one spring. There is one spring and there is one mass. So as we know that if in this case we are giving a displacement x to the system, we are giving a displacement x to the system. So with this single coordinate we can define the system completely. How we can define? Because correspond to this x, when we will give the x displacement to the system, so correspond to that we can calculate the spring force inside the system, we can calculate the acceleration of the system. So only a single coordinate is required to define the system completely. So such type of system, such coordinates is called as the degree of freedom. Now, what do you understand by the single degree of freedom? So if any system have only one number of independent coordinate which can define the system completely, that is known as the single degree of freedom. In order to define the system, if two independent coordinates are required, then such system is called as double degree of freedom system. For example, there is one more mass. There is one more mass that is attached to this spring. Now, is it possible to describe the system? Is it possible to describe the system, describe the complete system with only one coordinate, that is x? No, it is not possible. Why? Because if we are giving x1 displacement to this mass, then we cannot say that the x1 displacement will be of this mass m2 also. We cannot conclude that the displacement of this mass 2 will be x1. Why? It may be that you are giving a x1 displacement to the mass, that this mass is not moving, there is a compression occur in between this spring, so this mass have no displacement, or this mass have different displacement correspond with respect to this x1 displacement. So if only a single coordinate is not able to define the system completely, then there may be requirement of some additional independent coordinates. So on the basis of degree of freedom, we can also define our system. When only one coordinate is required, then the system is called as the single degree of freedom. And you are very glad to know that in your syllabus only single degree of system are there. That means for all type of system, you have only one coordinate which can define the system completely. For example, we are taking one pendulum. Can anybody tell me what can be the in what way it can perform the motion? In what way it can perform the motion, or which type of motion it will perform? Either it will perform the translational motion or it will perform the rotational motion. There is a pendulum. Which type of motion it will perform? Translational or rotational? Which type of motion it will perform? Translational or rotational? So as you have observed, in case of pendulum, each performs a type of rotational motion, because it rotates about this point. So in that condition, this theta coordinate, single theta coordinate is capable to define the system completely. So in this condition also, this system have single degree of freedom. But what about this type of system? What about this type of system? So can you conclude that if you are giving a θ1 displacement to this mass, then this mass will also have the θ1 displacement? Can you conclude this? No, you cannot conclude. For example, if you are giving the θ1 displacement to this mass, so the condition may be like this. That means this θ1 can explain the motion of mass m1 only. It cannot define the motion of this mass. So here a single coordinate cannot define the system completely. So this system will have 2 degree of freedom. Why? Because one theta is required to define the motion of m1, and for example, we are giving a θ2 motion for this mass m2, θ2 motion for this mass m2. Now this complete system can be defined with the help of two angles. So this system will have the 2 degree of freedom. Fine. So I hope now it is clear to you what is the single degree of freedom and what is the double degree of freedom, or what is the triple. For example, if you are adding one more mass, so it may be that mass. So in order to define that mass, there is a requirement of one additional one additional coordinate. So this system will have 3 degrees of freedom. So in this way, we can define the type of system on the basis of degree of freedom. Is there any doubt? If you have any doubt, then you can ask here. Now, right now I am giving a one question to you. Please tell me what is the degree of freedom of the given system? Is it okay? Now, can anybody tell me what is the degree of freedom for the given system? What is the degree of freedom for the given system? There is one pulley, and its mass moment of inertia is I. There is one point mass. So what is the degree of freedom of this system? What is the degree of freedom of this system? So in order to find the degree of freedom, always you will have to focus only on the inertial element. Is a single parameter, is a single coordinate can define the motion of all the inertial element? If it is, then it will is a single degree of freedom, otherwise it will be. So Vamsi Krishna is saying, sir, it have the 1 degree of freedom. So you are saying that it has 1 degree of freedom. Aman is saying that it have 3 degree of freedom. Akshat is saying it has 1 degree of freedom. So please clear this term. For example, because this is an inertial element and this can rotate, so 1 theta is required. 1 theta is required to define the system completely. To define this, define the motion of this disk, and there is one mass. So mass is traveling in linear direction. That means it will perform the translational motion. So one translation motion is required for this mass. Only 2 inertial elements are there. So only there is a possibility of only 2 degree of freedom. So there cannot be 3 degree of freedom. Fine. There is a possibility of 2 degree of freedom, but it have the 2. So as per this, we can see that there should be 2 degree of freedom. Then why are you answering this have 1 degree of freedom? Can anybody tell me? You are saying that this system has only 1 degree of freedom. But as you know, in order to define this, in order to define the motion of this disk, there is a requirement of one angular coordinate, that is theta, and in order to define the motion of this point mass, there is a requirement of one linear coordinate, that is x. So there should be 2 degree of freedom. Why you are saying that there will be 1 degree of freedom? Why you are saying that there will be 1 degree of freedom? Because if this thing is clear to you that why it has the 1 degree of freedom, then degree of freedom part is over. Anyone? Please guess why this system has 1 degree of freedom. Because this system can be defined. The system can be defined with the help of 2 coordinates. With the 2 coordinates. 2 coordinates are required. First, angular displacement x. First, angular displacement theta, and second, linear displacement x. Translational motion. Okay, Khyati, very good. So Khyati is saying translational motion is dependent on rotational motion of pulley. Vamsi Krishna is saying that because pulley is dependent on the mass. Exactly what is happening here. For example, if you are considering one point here and you are considering initial position here. So when this point will move from here to here, so same point will move from here to here. That means this distance is similar to this. So as you know, here the theta and x are dependent. As you can write, x is equal to r theta. So here x and theta are dependent. That's why this system have 1 degree of freedom. Because what is the definition of degree of freedom? It is the independent of number of coordinates. Because these 2 are dependent, so there is only one independent coordinate. If you are defining x, then you can automatically get the theta. If you are defining theta, then you can automatically get the x. So either x or r will be the coordinate for the system. Is it okay? I hope there is no doubt. Fine. Now, So this is all about the degree of freedom. Degree of freedom is over here. Right now I am going to do the analysis. Right now I am going to do the analysis for a undamped single degree of freedom undamped system with the help of two methods. And finally this class is over. We will see some problem on that concept and this topic is over. Fine. If you feel any doubt, then you can ask here. Fine. Now, okay, so there is one more classification. There is one more classification of the type of vibration. There is one more classification of the type of vibration that I am discussing here. Type of vibration. So this classification is done on the basis of motion of particles. Motion of particles. What is the motion of particle? On that basis the vibration is defined. So what are the types of vibration? First one is longitudinal vibration. Longitudinal vibration. Second one is transverse vibration. And third one is torsional vibration. Torsional vibration. Now, all three vibration can be understood with the help of one example. For example, I am considering there is one rod that is elastic in nature. And there is one mass that is hanged here. So if this mass is performing the motion in the longitudinal direction, if it is vibrating like this, along its longitudinal axis, then such type of vibration will be known as longitudinal vibration. And if it is vibrating like this, for example, this is one shaft and I displace this shaft and after that I release it. So in that condition you will see that you will see the transverse vibration, or I think you can see such type of vibration in case of beam, or you can see the example of transverse vibration. Please take one steel scale and hold it on one side and please deflect this spring at one end and you will see that scale will vibrate. So this is the longitudinal axis of that scale. So it will vibrate perpendicular. To that longitudinal axis. So this is the transverse vibration. Even you are displacing in this direction. So if it is vibrating like this is also the transverse vibration. Transverse vibration means vibration perpendicular to the longitudinal axis. And what about the torsional vibration? So for example, as you see that this mass is circular in shape. So if you are giving one angular displacement to the system, so what will happen? Because this rod is elastic in nature, so it continuously vibrates like this. So here the particles in torsional vibration, particles moves in a circle about longitudinal axis. Longitudinal axis. So such type of vibration is known as the transverse torsional vibration. Fine. So I hope these are very easy term: longitudinal, transverse, and torsional vibration. Transverse vibration mostly you will see in case of beam. So we will take one question on beam also. Fine. So this is nothing but the type of vibration. Now we are going to cover the natural frequency. Natural frequency of a spring mass system. So you can get a question from this topic only, that is the natural frequency of simple spring mass system. Now the orientation of a spring mass system can be any, so we will discuss the natural frequency in each and every case. So let us assume there is one spring. Initially there was a spring, and this spring is massless. This spring is massless, and its stiffness is K. Now is this spring will perform the vibration? Can anybody tell me? Can this spring will perform the vibration? If I will stretch this spring and after that I will release it, can it will perform the vibration? Because I have already told you, can it will perform the vibration? Please answer. I am not getting the response. There is a spring only, there is a massless spring only, and I am stretching this end, and after that I am releasing. So can this spring perform the vibration? Yeah, very good. It is massless. For a vibrating system, there should be restoring element which always try to restore the position as well as the inertial element. This has the restoring element, but it do not have the inertial element. That's why it cannot perform the vibration. Fine. So in order to make this system vibrating, we will hang one mass. So as you will see, when you will hang one mass, so this mass will try to stretch the spring. So when you will hang the mass, so what you will see some deflection. You will see some deflection inside the spring, something like this. So your spring will be stretched like this, and this is the initial position, and this is the final position, and correspond to the weight of this mass, your spring will be stretched. So we are assuming this is nothing but the static deflection. Now what do you understand by the static deflection? So I hope this term is very clear to you, because you have studied this term in strength of material. What is the static deflection? The deflection of any system correspond to any static force is known as the static deflection. For example, there is a beam, and you are applying a force at the end. So what will be the deflection? So in that case, you know, there is a permanent type of deflection, that is nothing but delta is equal to FLQ by 3I. So correspond to that force, the system will acquire a new position, and at that position the system is in equilibrium. System again, the system achieve a new position, new equilibrium position. This equilibrium position is known as the static equilibrium position. Whenever a system deflect by a static deflection and achieve a new position, that equilibrium is known as the static equilibrium. Now this is the original equilibrium of the spring. This is the original equilibrium, and this is the static equilibrium. Fine. Now the system have one restoring force, restoring element, that is a spring, because when we will displace the mass from its mean position, this spring will try to bring the system in its mean position or its equilibrium position. So this is the restoring element, this is the inertial element. Now this is the complete vibrating system. Now how you can get the natural frequency? So whenever you will get a question, so first you have to write this, because this is the physical model. So in order to calculate the natural frequency, we have to write its mathematical model. And as you know, in that condition, if K is the stiffness, so this mg force is balanced. Due to the K delta. Why? Because when we will draw the free body diagram, so it force is acting in like upward direction, and spring force K delta is in upward direction, because delta is what? Static deflection. So in this condition, the weight is counteracted upon by this initial spring force K delta. Right now in this spring there is a spring force, that is K delta. Now the system is in equilibrium. If you want to write the equation of motion, so we will discuss here two methods. To write the equation of motion. So first method is nothing but the force equilibrium. First method is nothing but the force equilibrium. So what is the force equilibrium? What does the force equilibrium says? Force equilibrium says that summation of all the forces plus inertia forces should be equal to 0. It is also known as the D'Alembert principle. I hope that you have already studied this D'Alembert concept in your engineering mechanics. So D'Alembert principle is used to write the equation of motion. Now, how we can write the equation of motion? So for that, as you know, in order to write down the equation of motion, first we have to deflect the system, because whenever you will deflect the system, then only it will perform the vibration. So let us assume we are giving x displacement, x dot velocity, x double dot vibration, x double dot acceleration to the system in downward direction. Because the system is accelerating in nature, so in order to bring the system in equilibrium, we have to introduce one inertia force. So inertia force always acts opposite to the acceleration. So when you will impose one inertia force opposite to the acceleration on the mass, then your system will come into equilibrium. And equilibrium means what? Equilibrium means your system, the net forces on the system is equal to 0. Now, so right now I'm here drawing one more diagram that represents the deflection from the mean position. So we are assuming from here we have given one x displacement, x dot velocity and x double dot acceleration to the system. So the system is accelerating in downward direction. So in order to bring the system in equilibrium, we will impose one D'Alembert force. So when we will impose one inertia force, so now the system is in equilibrium. But as you know, the system is displaced by a distance of x. So the spring force always acts opposite to the displacement and its magnitude is kx. Fine. Is there any more force? Apart from these two, is there any more force that is acting on the system? Can anybody tell me? Because right now we have drawn the free body diagram. So one mx double dot is acting in upward direction and opposite to the displacement, one kx is acting. Is there any more force on this mass? Can anybody tell me? No, sir. So if you are confused that sir, there will be a mg. So when you will consider the mg, then you have to consider that initial spring force also, and both are opposite in nature, so both will cancel out. That means the net force due to these mg and k delta, you will get 0. That's why we are not going to consider here. If you are considering, then put it here, they will cancel out. For example, I am considering here mx double dot. So as per the force equilibrium, because this by introducing one inertia force, we have bring the system in equilibrium. So mx double dot is acting in upward direction, k delta is acting in upward direction, kx is acting in upward direction, and mg is acting in downward direction, and it is equal to 0. And as we know, during equilibrium, mg is equal to k delta. So these two will cancel out, and what you will get? You will get mx double dot plus kx is equal to 0. And from here you can write x double dot plus k by m is equal to 0. So this is nothing but, this equation is known as the equation of motion, and you can see that this is nothing but, this is a type of something like this: x double dot plus omega n square x is equal to 0. And what is this? This is nothing but the equation of SHM, and it is matching with the equation of motion of the system. That means the given system is performing the vibration or the simple harmonic motion. So if you are interested to know the natural frequency, then what will be the natural frequency of a spring mass system? That is nothing but root k by m. What is the natural frequency of the system? That is nothing but root k by m, or here, from here you can conclude that mg is equal to k delta. So from here, if you want to know what is the value of k by m, so you can also find that it is equal to root g by delta. So you can also calculate the natural frequency by this formula, root g by delta. Is there any doubt, or is it clear to you? If there is no doubt, then we will see next method, and after that we will start the problem. Right? Is there any problem? Please respond. Because whenever you want to write the equation of motion, just give one initial deflection, initial displacement, velocity, and acceleration. Even you can give this displacement in upward direction, you will get the same response. You can do this at your home, because when you will give the motion in upward direction, so the spring will compress and the spring force acts opposite to the displacement. You are giving displacement in opposite direction, so you will impose inertia in downward direction. The spring force will act in downward direction, and you get the same unit of omega n. Very good. So Taizim is asking what is the unit of omega n. So unit of omega n is nothing but radian per second. Suppose in the examination he is asking the frequency in hertz. So how you can frequency in hertz? So you will divide this natural frequency with the 2 pi, then you will get the frequency in hertz. Suppose he is interested to know the time period. So if he is interested to know the time period, then 2 pi is equal, t is equal to 2 pi by omega. So from here you can get the time period, and it will be in seconds. So these terms are important. Now the same equation we are going to get with the help of one more method. Sir, please once tell the reactions. Prashant is saying, sir, once tell the reaction. Prashant, because we are giving some acceleration to the mass, so this is an acceleration, and we cannot consider this as an equilibrium, because when the body is in acceleration, that means there is some resultant force, net force, and for the equilibrium, net force would be 0. So in order to bring the equilibrium, what we do, we impose one inertia force opposite to the acceleration. So when we consider this inertia force, we will assume that the body is in equilibrium. Now, what about the spring force? Because the spring is stressed, the displacement of the spring is in downward direction, so the spring force always acts opposite to the displacement, so it will act in upward direction. Then please do the summation and you get the equation of motion. Fine. Now again we are going to derive the equation of motion with the help of energy method. Now what is the energy method? What is the energy method? Actually, these methods are not important for you, because they will not ask in the civil paper how to calculate the natural frequency for a given physical model, because that is this is in the syllabus of theory of machine for mechanical engineering, and that is a very deep concept. So they will not ask the natural frequency for a physical model. Simply they will ask the natural frequency for a spring mass system. That I have already told you. So remember this formula, root k by m or root g by delta. Delta is what? So when you hang the mass, in that condition you observe whatever deflection. So when you will put here, you will get the natural frequency. Now what energy method says? Energy method says that the total energy of the system remains constant. Why remains constant? Because inside the system there is no frictional force. No frictional force is there. That means when you will displace this system from here to here, so in that condition what will happen? It will gain such amount of potential energy, mgh, and when you will release this pendulum from here to here, so potential energy will degrade, but it will convert into the kinetic energy. So at this point potential energy is 0, but kinetic energy is maximum. That is equal to half mv square, and that is nothing but the total kinetic, total potential energy. And after that, because it has the kinetic energy, so it will move ahead. So now the kinetic energy is going to degrade, so it will achieve potential energy. So continuous conversion, or due to this continuous conversion of potential and kinetic energy, the system will vibrate. Fine. So because there is no friction, that means the total energy of the system remains constant. So right now we are going to draw the equation of motion with the help of energy of method for spring mass system. So in a spring mass system, the potential energy is inside the spring and the kinetic energy is inside the mass. So let us assume what is the kinetic energy of the mass. So kinetic energy of the mass is nothing but half mx dot square, because we are giving x displacement, x dot velocity, x double dot acceleration. So what is the kinetic energy of the mass? That is half mx dot square. What is the potential energy of mass? Potential energy of a spring, that is half kx square. And apart from these two, there is no extra energy inside the system. So this summation will always remain constant. This summation will always remain constant. Sometime total energy will convert into kinetic energy, sometime total kinetic energy will convert into potential energy, and sometime their summation will remain same. So at each instant of time, the total summation of the energy will remain the same. So with this method also we can derive the equation of motion. How we can derive? So for that we will differentiate the total energy with respect to time. So when we will differentiate the total energy with respect to time, then we will get the equation of motion. How can you get? So see here. So when you will differentiate, so you will get half m is the constant, the differentiation of x dot square, you will get x dot, and when you will differentiate x dot with respect to time, you will get the acceleration, and plus half k is constant. What is the differentiation of x square? You will get 2x, and what is the differentiation of x? That is nothing but x dot, and what is the differentiation of constant? That is 0. So from here, as you can see, x dot can be taken common, so it will come this side and it will become 0. 2 will cancel out. So from here you will again get mx plus dot plus kx is equal to 0. From here you can write x double dot plus k by m is equal to 0. K by mx is equal to 0, and again you will get omega n is equal to under root z by delta. Is it okay? Is it okay? Fine. Now, so this is nothing but the kinetic energy. This is nothing but the natural frequency of a spring mass system. And write down one note. Write down one note. What is that note? What is that note? That natural frequency of a spring mass system. If a spring mass system is independent of orientation of system. That means what does that mean? So it means either the system is like this, either the system is like this, or 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 the system is like this. For all type of single spring mass system, your natural frequency formula will be same, that is root k by m. But keep one thing in your mind, omega n is equal to root g by delta. This formula you can use for this system and for this system and for this system. Why? Because when you will apply one mass, when you will mount this mass over the spring, then you will see one static deflection in this system, you will see one static deflection in this system, and you will see one static deflection in this direction. So keep this thing in your mind. So keep this thing in your mind that you can use this formula for these three conditions only. Because when you will mount the mass on this spring, there will be no deflection. So this formula is valid for all type of spring mass system. So please remind this formula, and you will get the question on this concept only. Fine. So this is all about the natural frequency of a spring mass system. Now there is one more thing. This is the system with a single spring, but sometime you will get the combination of a spring. There is only one mass. Why one mass? Because we always deal with single degree of freedom system. So sometime you will get combination of spring. Now combination of spring means you will get more than one spring. Then what you will do? So as you know, when there is more than two spring, then the spring can be arranged in two manner. Either the spring can be arranged in parallel, or the spring can be arranged in series. So whenever the spring is arranged like this, whenever the springs are arranged like this, then how can you calculate the natural frequency of the system? So as you know, you can easily convert these two parallel spring in a single spring whose stiffness is what? That is nothing but K equivalent. How you can calculate? Because this concept you have already studied in which subject? Strength of material. So what you studied in the strength of material, when this K equivalent stiffness will have the same deflection under the same mass as that of these two spring will so correspond to this mass. If these two spring mass is showing correspond to this mass a delta deflection, then this spring will also show correspond to this mass a delta deflection. So this spring is equivalent to these two spring. So whenever the spring will be in parallel, whenever the spring will be in parallel, your equivalent stiffness will be K1 plus. And whenever your spring will be connected in series like this, then what will be your equivalent stiffness? This is K1, this is K2. So in this condition, you can also replace this system with a single spring whose stiffness will be K equivalent, and for such type of series arrangement, the equivalent stiffness you can get by this relation 1 by K1 plus 1 by K2. And this formula you have already derived in case of strength of material. That's why I am not dealing in detail with this formula. And when you will get the K equivalent, then you can easily calculate the natural frequency. Why? Because this is now a single spring mass system. So the natural frequency of such system can be get with the help of root K equivalent over mass. Fine. Is it clear to you, or is there any doubt? Now, how you will identify the springs in series? So keep one thing, whatever I am telling. So see here, whenever you will see whatever if both the spring is subjected to the same force, but their displacement is not equal to the displacement of mass. So what I am saying here, listen here, when the spring is said to be same, if both the springs is subjected to the same force, but their displacement is the same as the displacement of mass, then the spring is said to be in series. Force inside the spring is same, but the displacement inside the spring is not same of mass. The displacement inside the spring may be same. Inside the spring, displacement maybe it is x by 2, but it will not be same as that of displacement of the mass. Then the spring is said to be in series. Now what about the parallel? In case of parallel arrangement, the displacement of the spring is same as that of the displacement of the mass. What happens in case of parallel? In case of parallel system, the displacement of the spring is the same as that of the displacement of mass. Then such spring is said to be in parallel. Is it okay, or is there any doubt? Because if this term is clear to you, that if the displacement of a spring is same as the displacement of mass, then the spring is said to be in parallel. And if the displacement of the spring is not same as that of the displacement of mass, then the spring is said to be in series. And after that, if there will be more spring in parallel, then your formula can be extended in like this manner. I hope now it is clear to you. Now we will see one more concept. Natural frequency of the beam. How you can natural frequency of the beam? So right now we are going to discuss here transverse vibration. Transverse vibration. So how you can calculate the transverse vibration, because you are civil students, so you can expect the question from the topic. So how you can do transverse vibration? So let us assume there is one beam. So how you can calculate, and one load is acting here, one mass is placed here, and this beam is massless. When you will get the question, you will always get that the beam is massless and one mass is placed here. Then what is the natural frequency of the system? So what will be the natural frequency? The natural frequency will be same as under root k by m or root g by delta. But how you can calculate the stiffness of that beam? And so you know the deflection of the beam, because k is equal to what? K is equal to nothing but it is W divided by delta. What force is acting on the beam? That is nothing but mg. And what is the deflection under that mass? So when you will deflection place here, so in this case, as you know, it is mg Lq over 3ei. So from here you can calculate the stiffness of the beam, and you have already value of the mass. When you will put here, you get the natural frequency. Or otherwise, what is the simple formula? Simple formula is what? Omega n is equal to root g by delta. Delta is what? Delta is nothing but the static deflection under the mass. So which deflection you will consider? For example, your mass is placed here. Your mass is placed here. Then which delta you will consider? As you know, the beam will deflect like this. So you will always consider the delta under the mass. You will not consider this maximum deflection. You will calculate this deflection with the concept of strength of material, and you will put in this formula, you will get the natural frequency. Now the question may be asked from the cantilever, the question may be asked from the simply supported beam. So let us assume the mass is placed here. So in this case, if the mass is centrally placed, so in that condition, what is the deflection? So as you know, in this condition, the deflection is nothing but WLQY 48 EI. E will be given to you, I you can calculate. So when you will calculate the delta, put in this formula, you will get the natural frequency. So in this way, you can calculate the natural frequency of any system. And here the concept of single degree of freedom is over. If you have any doubt, you can ask. Otherwise, we will solve the problem. So can we start to solve the problem? Can we start? Because with the help of problem, you will get the clear understanding. So can we start? Please respond. I am not getting the response. Okay, so I am going to start the question. So just see the question slide here. Okay, so Taizim is saying, sir, can you explain the term? In the formula once more? Okay, so the natural frequency is nothing but root k by m, where k is the stiffness of the system. Because it causes the restoring force. M is nothing but it is the mass or the inertia of the system. And when we will use delta, so delta is nothing but the static deflection under mass. Static deflection under mass, we have to always consider the static deflection. I am again quoting here, under the mass, not the maximum. Fine. And what about the I? Because when we use the formula, most of the time we will get the E. So in that case, E will be modulus of elasticity that will given to you, and you will deal with this term only when you will get a problem from the beam. So modulus of elasticity, E is modulus of elasticity. Elasticity, I is nothing but the area moment of inertia. The beam may be sorry for the interruption. So right now we will discuss. I hope you have noted all the terms. So right now we are going to start the problems. So problems are here. Some problems are, one problem is from civil engineering. This problem was asked in 2019 in civil engineering paper. So can anybody tell me what is the answer for this question? Please hurry up. Give me the answer fastly so that I can cover the maximum number of problem. So please tell me what is the answer for the system. A simple spring mass system consists of a mass M suspended from a spring of stiffness K, considering Z as the displacement of system at any time T. The equation of motion for the free vibration of the system is. So equation of motion is already given here. And he is asking what is the natural frequency. Can anybody tell me what is the answer? Very good, Akshat. So it is nothing but D. This thing we have already proved. So as you can see here, this question was asked when it was not in your syllabus. That means in upcoming papers, you can easily expect the question from this topic. Now, for the rest of the problem was asked in the mechanical paper, so you can get the similar type of problem in your examination. So right now we will discuss here. Now see. A point mass is executing simple harmonic motion with an amplitude of 10 mm. Can anybody tell me what is this value? Please respond fast. What is this value, 10 mm? What is this value? 10 mm. Point mass is executing simple harmonic motion with an amplitude of 10 mm. So 10 mm is nothing but the maximum amplitude A. It is given 10 mm. And he is saying that it is vibrating with a frequency of 4 Hertz. 4 Hertz is given. That means it is given 4 Hertz. So can we calculate the omega here? Yes, we can calculate. How we can calculate? This is nothing but 2 pi f. So from here you will get 8 pi. Now he is asking what is the maximum acceleration. If the A is given, omega is given, can you tell me what is the maximum acceleration during SHM? Because I have already told you. What is the maximum acceleration during SHM? A omega square. Very good, Taizim. It is nothing but the A omega square. So you can easily get the maximum amplitude of acceleration, that is x dot maximum is nothing but A omega square, and that is the answer only. So use this in meter because he's asking in meter per second square. So this is nothing but 10 divided by, and you get the answer. This is the answer only. Fine. Can we proceed for the next problem? See here. The natural frequency of a simple spring mass system is omega n. This is a conceptual question. The natural frequency of a spring mass system is omega n, and the natural frequency of this system on the moon, if G moon is given as Z Earth by 6. Can anybody tell me what will be the natural frequency? Khyati, you are telling me the answer for which, for second question or for the prior one? So Prasant, you are saying 160. So right now I'm solving question number 2. So please tell me if so. Somebody is saying that Aman is saying that answer will be B. As I already told you, please see the concept here. As you know, omega n is equal to root k by m. Either you can use this formula or you can use this formula. Fine. He is saying on the moon G is changing, but as you know, when the G will change, correspond to that delta will also change, because what is from where delta comes? Delta is nothing but it is the deflection correspond to the gravity force. So when you are experiencing mg force, so correspond to that delta will be different, and when you will experience mg by 6, so correspond to that delta will be different. So when your G will change, the delta will also change in the same proportion. So it will change in the same proportion. That means what you will get? You will get the same frequency. Otherwise, what is the another approach? As you know, K is nothing but it is the material property, because K is the stiffness of the spring, and it will not change either you will at Earth, or you will at moon, or you will at sun. So it will not change. In the same way, mass is the quantity of matter. It will also not change due on the Earth, on the moon, or on the sun. So if K is not changing, M is not changing, then obviously its natural frequency will not change. Then omega is the correct answer. Khyati, very good. So the answer for this question is nothing but omega n. So never confuse with this question, because this is a very good question. If the G will change, correspond to that delta will change, because he is not saying that for the same deflection. He is saying for the same system. So when the gravity effect will reduce in the same way, so your deflection will also reduce, so the ratio will remain same. That means natural frequency will reduce. Now come to the next question. So can anybody tell me, because right now we will seeing the couple of questions, some we will solve, and about some question we will discuss the concept only. So can anybody tell me here the springs are in series or parallel? Can anybody tell me here the springs are in series or parallel? Yeah, Khyati is saying it is in parallel. So I am waiting for the more responses. Please respond, everyone. Here the springs are series in parallel. Very good, Taizim. So as you can observe here, if we will give the x deflection to this system, this spring will compress by x, this spring will elongate by x. So in all the spring, that deflection is the same as that of the mass. So this system will be, so the spring will be arranged in parallel. Aman, this is not in series. This is not in series. Because I already told you, in case of series, your deflection of spring will not be same as that of the mass. Here, as you can see, the deflection of the spring is same as that of the mass. That's why the spring is in parallel. Fine. So very good, Prasant. So as you know, so from here you can easily calculate the K equivalent. So what will be the K equivalent? That is K1 plus K2. That means 4,000 plus 16,000. 4,000 plus 16,000. So you from here you will get 1,600. So you will get 2,000 here. You have the value of K equivalent. Then you can easily calculate omega n is equal to root K equivalent by m, and from here you will get the answer. So Kathy is saying that I hope she is getting 12, but from here you will get the omega n in radian per second. So please see the unit also. So whenever you will get, he is asking the frequency in hertz. So please divide that omega n with 2 pi, and you will get the frequency in hertz. I hope now you can solve this question. Now come to the next question. This question was asked in the engineering service mechanical subject. So can anybody tell me what is the equivalent stiffness? Because he is asking what is the combined spring constant of the system. Can anybody tell me what is the equivalent stiffness of the system? Very easy question. Even you can tell me the answer by seeing this diagram only. Anyone? What is the equivalent stiffness? Sir Taizim is saying, sir, what is the answer for third question? Taizim, I will have to calculate this. So just wait, I am calculating this. This is 2,000 divided by 1.4. So the frequency in radian per second you will get 37.79 when you will divide it by 2 pi. So when you will divide it by 2 pi, so sorry, 2,000, that is 4,000. Okay, this is 4,000. I am not correct here. This is 4,000. This is 5600. This is my mistake. So when you will write 5600 here, 5600 here, when you will divide it by 1.4, after that taking the square root, you will get 63.24 radian per second. And when you will divide it by 2 pi, then you will get 10.06. So answer you will get B, 10 hertz. This is not 12. This is B. Fine, 10 hertz. In the same way, please tell me the answer for this one. 4. Please tell me the answer for this question. Tell me, here the springs are arranged in series or parallel. This time Aman will tell me that springs are arranged series in parallel, because last time you give me wrong answer. So Aman will tell that here springs are series in parallel. So Prashant is saying that answer is option B, and Akshat is saying answer is option B. Kathy is saying option B. So exactly here, as you can see, if you will give the x displacement to this system, but Taizim is saying it is K1 plus K2, not Taizim. It is not K1 plus K2. When you will give the x displacement to this, so K2 spring will experience x, this is experience x, this is experience x, this is experience x. So all the springs are in parallel. So what is the equivalent stiffness? That is K1 plus K1 plus K2 plus K2. So that means you will get 2K1 plus K2. I hope it is clear to you. So you will get the B as the answer. Fine. Now, this question for you as a homework. Please tell me in the comment box. K1, K2 are arranged. K1, K2 I am considering 1, and after solving this we will get K equivalent, and K equivalent and K2 I am considering this 2. Tell me 1 is in what order and 2 is in what order. What is the order of 2 and what is the order of 1? If you are able to tell this, then you will get the answer. Tell me in one system how the springs are connected, and in second how the springs are connected. Because when we will solve this, we will get one K equivalent, and the K equivalent and K3 will be in second order. So what is the order in first arrangement and order in second arrangement? Please tell me. So one in series and second in parallel. Very good, Taizim. So Akshat is saying first for series and second in parallel. So if you are able to get this, then you can easily solve this question, because after solving, this is K equivalent 1. So after solving, you can get K equivalent like this. This is K equivalent 1 plus K3. From here you will get net equivalent of the system, and from here you will get the omega n, because he is asking in radian per second, and you will get the answer. Fine. So now we are going to the next question. Again, you can tell me the answer by seeing this diagram. And this question was asked in mechanical engineering for 2 marks. And it will not take more than 5 seconds to give me the answer. Can anybody tell me what is the natural frequency for the system? Can anybody tell me what is the natural frequency for system? Very good, Bamsi. Very good, Taizim. As you can see that, as we know, that natural frequency of a spring mass system is independent of orientation. So here the orientation is this. That means the natural frequency is something root k equivalent k by m. But here 2 springs are used. That means we have to calculate k equivalent. So when we will give x displacement to the mass, then you will get x stretch on this spring, s compression on this spring. That means 2 springs are in parallel. So the k equivalent you will get k1 plus k2, and finally you will get the answer. So you can easily score 2 marks. Fine. So most of the people have given me correct answer. So very good, Vamsi, Taizim, Khayati, Akshat, and Aman. Very good. Now these 2 questions are related to the beam. So this question I will solve here. This question I will solve here, and you can also take 2 minutes to solve this question. And this question, for this question, I'll give you the concept. So this is for your homework, and please solve this question. When you will get the PDF, for this session, you will get the answer on that PDF, so you can cross check their answer. Fine. So first I am explaining here. So if the length of a cantilever beam, so he is saying there is one cantilever beam. So in the second case, he is reducing its length by half. So first case, if it is the length L, then in second case, cantilever beam has a length of L by 2. Then the natural frequency of the mass at the end of this cantilever. So the mass is placed at the end of cantilever. So he is saying that if in this case the natural frequency is omega n, if in this case the natural frequency is omega n, then by how much factor the natural frequency in second case will increase. So first you will calculate the natural frequency for this case. So as you know, for beam we will always use omega n is equal to z divided by delta. Delta is what? Delta is the deflection under the mass. So you know what is the deflection in the cantilever beam at the end, under the mass. So because the mass is placed at the end, so we will consider the deflection under the end. So it is nothing but z divided by mzlq by 3i. So it will come in numerator. So from here gc will cancel out. That means omega n you will get under root 3ei by mlq. Now, as you can see, natural frequency is dependent on E, I, M, and L. For second condition, neither E is changing, neither I is changing, neither M is changing, only L is changing. That means we can say that omega is inversely proportional to this term. So we can write it as omega 1 first case, omega second case. So this will be equal to under root L in second case q, L in first case q. So when you will write, this is nothing but this is L by 2, L by 2q, L by 2q. This is LQ. So LQ will cancel out, and here you will get omega n by omega n first by omega n second. You will get 1 by root 8. So from here you will get omega n second. Omega n second is equal to under root omega n second is equal to root 8 omega n 1. So Prashant gave me B as the option. Prashant gave me B as the option, but here option C is the correct answer. I hope there should not be any doubt. So in this way you can calculate the natural frequency of the system. Now come to the last question of the session. So here we will see last question. Consider a cantilever beam having a negligible mass. So it is mentioned here, there is a cantilever beam having the negligible me what is the flexural rigidity? Can you tell me what is the flexural rigidity? So flexural rigidity is what? This is the strength of material term. What is the flexural rigidity? Anyone? I am waiting for the response. EI, very good Taizim, very good Akshar. So he is saying it has the uniform flexural rigidity I. L is given 0.01 meter. L is given 0.01 meter, and frequency of vibration with a 0.5 kg mass attached at the free tip. So here 0.5 kg mass is attached, so M is given 0.5 kg, and the frequency is 100 hertz. Can you tell me which parameter is this? Can you tell me which parameter is this? Tell me please. Which parameter is this? $100 hertz. Yeah, very good, Vamsi. Taizim, do not confuse that this is omega, because for omega unit is radian per second. It is given hertz. That means F is given, so that is nothing but 100 hertz. We can easily calculate the omega here, because why? What is omega? So omega is nothing but 2 pi F. So from here you will get 200 pi radian per second. Now he is asking what is the flexural rigidity. Then how you can calculate? Omega n is equal to under root z over delta. Now what is the delta for this case? So for this delta is nothing but mg lq, because this is the force. LQ divided by 3I, so it will come 3I. ZZ will cancel out. That means omega n you will get under root 3EI by LQ. Mass is given, omega n is given, length is given. Can you calculate the EI here? Yes, you can easily calculate the EI value from here. Whatever you will get, that will be the answer only. And this is the last question of this session. If you have any doubt, you can ask. Otherwise, the session is over. You have any doubt, please respond. Do you enjoy the session? Did you enjoy the session? I hope now there will be no question that will be left from this topic, or you will miss from this topic in the examination. Fine. So from here you can easily calculate the value of EI. So with this, and I will give this PDF will be available to you after some period of time. And weight is MDOF. Little bit explain what is Akshar. Akshar is saying, sir, what is MDOF? I am not getting MDOF. Akshar is saying, what is MDOF? Please, can you explain MDOF? What do you want to know? Multiple degree of freedom. Okay, so as I already told you, a system which requires only one coordinate to define the motion of system completely, that is known as the single degree of freedom. And when two coordinates are required to define the complete motion of the system, that system is known as the 2 degree of freedom. And when we talk about the 3, 4, 5, 6, 7 and number of independent coordinate, that all the system comes in the category of multi-degree of freedom system. Fine. So whenever even 2 degree of freedom system is also a multi-degree of freedom system, but when we talk about the vibration chapter, so it is mentioned there: single degree of freedom, 2 degree of freedom, and multi-degree of freedom. We will never discuss about the 3, 4, 5. We will consider all these 3, 4, 5 independent coordinate system as multi-degree of freedom system. Is it okay? So this is all about the multi-degree of freedom system. And this session is over here. So thanks for being up to the last. And students who wants to join the Hindi session on the same topic, they can join the session today at 1 p.m. on the Gate Academy Hindi channel. So for similar type of video, please subscribe our channel, and if you think that this session is helpful for you, then please share this session with your friends also. Thank you very much.